algorithm, toe beans.
Hello, everybody. Welcome to OpenCV Weekly Webinar. And today I have with us the CEO of Roboflow, Joseph Nelson, who has been with us several times. And every time he brings a lot of value to this webinar. Also with us is Phil Nelson, who is the Director of Content and Creator at OpenCV. Phil, how does this webinar go?
Good that you should ask that, Satya. The way this works is that we have a 40-minute presentation from our guest here, Joseph Nelson, after which I will be doing a giveaway to one lucky member in the audience. They will win the OpenCV course of their choosing, as well as a Roboflow swag bag if they are in the United States. If you're not in the United States, we will get you some Roboflow GPU credits instead, just to make sure that everybody can get something. Thanks a lot, Joseph. I appreciate that. We're also taking Q&A from you in the audience, so please use the Zoom Q&A button to ask any questions you may have during the show, or if you're watching on one of our streaming platforms, please feel free to ask your question in the comments, and we will make sure that we get to those if possible. Also, we are taking naming suggestions for the cat. Please send those suggestions to newsletter@opencv.org. Back to you, Satya.
That's great. And, we will continue with our series. I think Roboflow has become the fellowship of YOLO, right? We have gone over, I think, Yolo V3 also we went through, and Yolo V5. And now we are going to talk about Yolo V7 today. And Roboflow is great because they have been doing their own internal tests. And we are going to see what those tests reveal. Even on learnopencv.com or a blog post, we have Yolo V7. It's making quite a splash in the object detection world. So we are glad to have Joseph on the show again. Welcome, Joseph.
Thank you, everybody. It's a pleasure to be here. Yeah, it's kind of like I made the joke, a new YOLO called Roboflow. So I'm working on the copy a little bit. But, we'll have a good time of going through a tour de force of the YOLO family and zooming in on Yolo V7.
You could have called the company YOLO Flow. What were you thinking?
If only.
But is YOLO the most popular model on what people use on Roboflow for object detection? The YOLO family, if you consider?
If you aggregate the YOLO family, yeah, I'd say it's the majority minority detector that people will use. For classifiers, there's probably quite a bit of interest in the transformer family, VIT. In segmentation, there's a lot of interest around YOLO Act has been pretty prominent. YOLO Act, as some will say.
We talked about this with Onyx last week. Do you pronounce it ONNX or Onyx? In this case, it's YOLAC. I like that one.
And then, in the segmentation world, there's models like Segformer and others. But yeah, I think the YOLO family models are among the most popular for object detection, largely because of how approachable they are, both from a compute requirement perspective, the level of community that's emerged around them, tutorials, content, ease of use. And I think that's a trend that continues with Yolo V7, and we'll dive into that.
Even though they are from very different groups. Yolo V3 was from a different group. V3, depending on which version you want, right? So V3 and V5 are related if you look at the PyTorch version. And similarly, V3 and V4 are related if you look at the darknet version. But then this is a different group. V7 is a different group. It was the same people who wrote scaled YOLO, right? So
yeah, the Yolo V4 author, Alexei Borchovsky, is one of the named authors in the Yolo V7 paper. And then One Yu, who worked on Yolo R between Yolo V5 and Yolo V7, is one of the authors on the Yolo V7 paper as well. So it's kind of like, it's like a family reunion, I guess, of a paper. Everyone, the gang's getting back together from prior versions and come together to contribute their best to create what can be the current state of the art on COCO object detection benchmarks.
Excellent.
That's great.
All right. It's your show, Joseph. Take it away.
Sure. Yeah. So, I thought it'd be fun to dive into little introductory stuff at the beginning. I know Satya always likes to joke that it's funny I introduced the OpenCV team, but it's always useful for you all to get a chance to say hello and just how big the community is and why we're so happy to be supporters and evangelists of OpenCV technology just as much as computer vision more broadly. So I'll talk through some of that. Then I'll introduce Roboflow a little bit, and then we'll drive right into the Yolo family and Yolo V7. What makes it new? How good is it? Should you be switching all of your architecture tomorrow? And actually some custom benchmarks as well. So stay tuned for, we'll drip that in at the very, very end. So first things first, of course.
Benchmark-a-mania running wild at the end is what you're saying.
Yeah, benchmarks are all over the place. First things first, of course, you're... Phil, I got to get you on this slide, man. That's on me. So
well, the correct label would be your co-host with the co-most. Had to get that in
there. Next round. But yeah, I think it's useful to introduce OpenCV. I mean, for over 2 decades, you'll have been the foremost library that ushers in the ease of use in computer vision. And I think the recent kind of expanses of including the ability to have courses, consulting, and even hardware with the Oak devices. And we see those as incredibly popular among the Roboflow computer vision community and even more broadly. So Satya, I don't know if you have anything to kind of add here for folks that know you all quite well, but I think it's always good to acknowledge and recognize the incredible impact OpenCV has and continues to have on ushering in computer vision.
Yeah, so OpenCV has been around for 22 years. In fact, when I was a grad student, I used OpenCV myself for my research work. And it's been an incredible library. Intel has supported us for the longest time, and this library has grown to over 2,500 optimized algorithms. So, and it also has a DNN module where you can run all the deep neural network architectures. About courses, I want to thank Roboflow. Recently, we had done a Kickstarter campaign for a TensorFlow course, and as part of the campaign, we had a stretch goal where Roboflow added one module to our offering. So we have active learning module from Roboflow it's a separate course. It's a short separate course. But it was part of that Kickstarter campaign. So many thanks to Roboflow for doing that for us. So that's about OpenCV.
I actually pulled up a slide here that introduces that course exactly. So yeah, it's about active learning with computer vision. Participants that enroll will go through everything from collecting data sets to building things and deploying them to an Oak. Specifically, it's building a empty parking space detector. So as you return to the office and you're like, is my spot open? Is it taken? Should I even drive today? Maybe I should bike or take public transit. You can build your own sort of little device to let you know how full or empty a given parking space is. But of course, the techniques are applicable across really any kind of vision problem that you want to tackle and solve. And Mohammed Traore and the Roboflow team has done a fantastic job of putting that together. And he even noted for folks that register for the free course, I think before the end of the week, that they get a learn-along session with Mohammed. So you'll have a special Q&A and almost like a co-work session for those that want to enroll and learn. And it's high-quality content, and we're pleased to be able to offer it to the OpenCV community.
Yeah, Mohammed's great.
Yeah, so one thing to note is that even though this course was initially for only the people who took our TensorFlow course, anybody on this webinar who wants to go through the course, please send us an email at courses@opencv.org, and we will enroll you in the Roboflow course.
Awesome.
A little bit about Roboflow. So we make building blocks for developers to create production computer vision applications, and it spans a wide array of industries, everything from identifying gas leaks to tracking tennis balls, measuring fish, identifying plant diseases, everything in between. And of course, to build computer vision applications, you need production-ready infrastructure, everything from collecting and organizing tools, so using the Robophil open source PIP package for identifying what data to collect and which video frames you want, organizing that data, including doing annotations, automating annotations with model-assisted labeling, understanding what data should be labeled next is all useful critical steps. Doing pre-processing and augmentation, so increasing dataset size and representation and getting the most out of data you've collected. Training models, whether that's training with open source model library like models.roboflow.com, where we talk through the YOLO family of models and more, like faster RCNN, MobileNet, and others, as well as training directly in Roboflow, which allows a model to be immediately usable in production on a hosted API or deploy anywhere. And so with Roboflow, you can easily deploy using, again, the Roboflow Oak pip package, for example, to deploy to an Oak device, or you can deploy to Luxana or a NVIDIA Jetson. You can deploy to iOS and iPhone devices, and it optimizes models to run at up to 60 FPS. I think the upper bound is limited by how fast Apple lets you use cameras or images from the camera frame. Deploy directly in web browser. You can use TFJS. The TensorFlow team just highlighted Roboflow's evangelism for thousands of developers that are building web-based applications, and then continuing to improve and display those results and continuing that cycle along the way. So chances are, if you're working on computer vision applications and infrastructure, we can help accelerate and improve the means of doing that. And of course, it's a developer tool. It's all free to get up and going, and away you can go. And we do quite a bit to do education as well as tutorials along the way. So better data, better models, deploy anywhere, improve easily. That's kind of a way that we think about it. We also introduced, actually it's the 1 year anniversary, funny enough, very incidentally, we didn't plan that this way, I actually just now kind of realizing that, of what's called Robophil Universe. Basically the community of individuals that are creating data sets and sharing those data sets, as well as some models trained on top of those data sets for others to build and use from, is open for people to build and create new applications with. So there's over 66 million images, 90,000 data sets, 7,000 pre-trained model endpoints, everything from, say, finding soccer balls to counting sheep in aerial imagery, counting surfers on the beach, finding sharks, seeing if someone has a mask, not mask, reading license plates, really kind of anything you can envision. The community is creative and they build things for it. I mean, we had someone that made I think I talked about this in the webinar, that made a workout machine for their cat. Small plug to remember to find a name for the cat on the OpenCV webinar. But they basically found a little robotic arm attached to a laser pointer, trained a model to recognize their cat, and told the robotic arm to constantly point the laser pointer 10 feet away from the cat at all times. And there's this video of the cat jumping around the living room as it's getting its exercise, which frankly is probably more exercise than I did in my living room during COVID. It was enough for me to be inside. I wanted to get outside for sure, my bike and run, as well as other people that have made, of course, production applications and supporting over half the Fortune 100 that make things like Walmart and retail or manufacturers or healthcare, everything in between. So Robophil Universe is versioning community that aims to continue to make computer vision more accessible, open, and usable. In fact, that's a good transition. We actually used Universe in the community to help inform the quality of Yolo V7. So that's a little bit of a cliffhanger, if you will, of how does Yolo V7 do on this diverse set of imagery. I see some notes in the chat for congrats to Robophil on a first anniversary of Universe. Really appreciate it. It's really a thanks to the community is what makes it work. So thanks to you all. All right. So as I said, the bad line, new YOLO called Roboflow. Let's dive in. So before we dive into Yolo V7, I wanted to give some background on the YOLO family of models. And Satya, Phil, of course, feel free to chime in with thoughts and background. But we kind of get our start in 2016 when Joseph Redman introduces YOLO. You only look once at CVPR. It won People's Choice Award, so it was an early sensation. It was novel because it single pass across the image. A lot of models at the time, including things like RCNN and faster RCNN, were two-stage detectors where they would first figure out which parts of the image are interesting to look at and then kind of run a classification model on top of that. YOLO says, let's use anchor boxes and slice the image and actually do a single pass of an image through a network. Let's make it small, let's make it usable, let's make it accessible. And that was a pretty notable, clearly lasting impact on the field. So the very first YOLO model was introduced in 2016 and to great fanfare.
Yeah, and the other distinct thing about YOLO, the first version of YOLO, was that it was based on darknet framework. People usually use TensorFlow or PyTorch, but this is a completely different framework written in C. I think it was not even C++, it was written in pure C, so that it was very portable across different devices, etc. And so that also stood out, that not only they created a new model, they actually had the whole new framework to go with it.
That's exactly right. I mean,
And it all worked.
and it all worked. Yeah. So, I mean, the maintainers of original YOLO are also some of the maintainers of Darknet, which actually, we talked about Alexei Borchovsky. He was one of the key contributors to Darknet. And we'll get to this, the author of Yolo V4. So it's kind of like a natural evolution as the YOLO family models continue. Now, introducing YOLO family models is not complete without talking about Joseph Redman's resume. And I'm sure some viewers of this show are familiar with the infamous Joseph Redman resume. But I think it's always a fun thing to shout out that we can do this serious work and we can have fun while we do that serious work. So maybe folks are familiar, but I included a little screenshot of the resume here, and you can see Joseph Redman, who introduced the YOLO family models, is also a creative background individual. Everything from studying math to going over to UW or University of Washington to release some of his creations. He actually has since departed the computer vision research field and recently tweeted that he's been working, or he did a show with a circus. Like I don't know if you're familiar with some of the show acts that you can do with bands and ribbons, but he posted a video of himself. So he's a pretty dynamic guy. It's pretty impressive, the range he has in his career.
I believe they're called silks.
Silks, not ribbons. Thanks.
Whenever you need some Carney terms, send it my way.
You know what's funny is I should have known that. Maybe I shouldn't admit this publicly, but I took a trapeze class for a while, and there was a show that was going to happen, and we all had our tutus lined up. And believe it or not, I tore my ACL before the show, so there's no video of the show. Maybe for better or for worse. But there would always be folks practicing silks while we were doing our trapeze practice.
You've got a new nickname from me now, the Flying Iowan.
Deserved. So, I mean, continuing, the first YOLO model kind of grows with a splash. Folks get excited about it, CVPR. And then Yolo V2 actually was never released. Fun fact, it was Yolo 9000 was the name of the paper. And then we went right to Yolo V3, which gained a lot of popularity and was introduced in 2018. I recommend reading the abstract. I think this is the most approachable paper in computer vision research. It's very casually written. It's kind of fun. I mean, it starts with a line, sometimes you just kind of phone it in for a year, I didn't do a whole lot of research this last year. And then he kind of walks through some of the things that he introduced. So it's a fun read. And Yolo V3 is kind of, while it's noted as an incremental improvement, continued to accelerate the rise in adoption and proficiency of, in computer vision, there's kind of been historically mega models that if you are the resources of Google and Amazon and Facebook and Microsoft, maybe you can train and deploy. But YOLO kind of represented this almost maybe more hacker or like indie approach where you didn't need giant GPUs and you could train computer vision models, and that really democratized the field. And Yolo V3 was really a watershed moment in that democratization, and it kind of set off a bunch of additional changes with more YOLO family of models. And so I want to talk quickly through some of those family of models because each of them have contributions and roots for what get us to Yolo V7. So after Yolo V3, we have Yolo V4. And Yolo V4 was the first one without Joseph Redman as a primary author. Alexei Borchovsky, as we described, was one of the maintainers of Darknet and introduces Yolo V4. Some of the key things Yolo V4 did is introduced a lot of bag of freebies, actually not in the model architecture itself, but in the augmentation pipeline that happens at training time. So for example, there's an augmentation known as mosaic augmentation, where you kind of, as the name described, take pieces of your images and your training data and you keep the annotations on each of those, but you slice it up and almost make like a mosaic of, you can imagine like 4 window panes, except the windows are maybe not equal in size. And things like this that increase the performance as almost like a bag of freebies as a part of training, they so called it. As well as a few other changes to improve the speed, and some marginal improvements to Yolo V4. Yolo V4 was still released in Darknet as described, so a little bit harder to adopt from I think the broader community, but still a notable improvement with a paper release to document those improvements. You can see that it improves on the COCO object detection benchmark compared to Yolo V3 in the upper right hand. Now, this did introduce the first kind of naming controversy. People were like, can you say it's YOLO if it wasn't Joseph Redman? And thank goodness Joseph Redman is active on Twitter. So he put out some of his notes. He said, doesn't matter what I think. At this point, Alexei AB has maintained the canonical version of Darknet YOLO. He's put a ton of work into everything. Whatever he wants to use, not my problem. So I really appreciate the ethos of Joseph Redman basically saying, whatever model you want to use, whatever name you want to use, go ahead and go forth and do your research. The next model that was introduced is Yolo V5, which is even greater divergence and maybe a more, sometimes even more loose introduction to the Yolo family, because it didn't have a release at the same time as a paper. And so Glenn Jocker and the Ultralytics team introduced Yolo V5, and the Yolo V5 notes that some of the goals as to why Glenn introduced it were here in this GitHub comment. Specifically, it wasn't just about performance in terms of accuracy and speed, but it's about ease of use. It's about exportability. It's about memory requirements. Mean average precision, of course, is important, and also the market size, Glenn notes. And I sort of think about this like YOLO for developers. Like, we're kind of like taking this and we're porting it to PyTorch, which is notable because Glenn at the time was maintaining a Yolo V3 version, but instead of maintaining it in Darknet, he was maintaining it in PyTorch. So he took his fork of Yolo V3, added a lot of these improvements, and pretty soon he realized that, what he'd sort of been maintaining with Yolo V3 was maybe its own YOLO version. So he introduces it to the Yolo family. He goes, cool, I'll just call it Yolo V5. I'll put it out there, and the community will begin to use and adopt it. And to this day, Yolo V5 continues to be an incredibly popular repo. It's about to cross 30,000 stars. It's one of the most popular AI repos there are, let alone in computer vision. So I kind of think about this as the transition from computer vision in research to increasingly in industry.
If you want a deep dive on Yolo V5 and Ultralytics from the horse's mouth, Glenn was on an episode of OpenCV Weekly Webinar a few weeks ago. You can find that in our YouTube archive.
So one comment I want to make here is that when you're looking for some popular, if you want to make something popular, it always helps to latch on to something that is already taking off, like PyTorch. And so YOLO was popular and PyTorch is popular. They were both taking off. So the combination of the two, it just was fuel it just fueled the growth of Yolo V5, in my opinion. And that, Yolo V5 and ease of use. Yolo V5 is actually very nice to use, easy to use. So, but the fact that PyTorch was growing and the Yolo name was so popular, both of them contributed to this massive growth.
I think those are all true statements. What do you think, Joseph?
Yeah, I think the latching onto both PyTorch ease of use and the YOLO name were huge. I think also Glenn did a fantastic job of kind of focusing on like the developer experience and putting that primary in terms of the ease of adoption. Of course, the selection of using PyTorch is part of that, but even if something in PyTorch that doesn't immediately make it usable, I've used some pretty bad packages in my day. And I think Glenn really focuses on listening to what's going to make things easier to adapt and bring into independent code bases. And in fact, that's actually why Roboflow is the official dataset management tool of Yolo V5. So if you're on the repo and you go and prepare data, because we see pretty similarly about increasing access and democratization and ease of use as incredibly important. So like all the custom training tutorials, all the custom dataset management, you'll find that we are tight partners of encouraging and using whichever model developers want. And often Yolo V5 is an easy place to get started.
Great. Love to see those collaborations.
Actually, you guys have done a very good job of collaborating with several people. Even with OpenCV, if you think about it, right? When we ask you for help with courses, you jump in, right? Webinars you have been collaborating on, and also ModelPlace.ai. You guys have been great partners there. So great job there. I see you partnering with a lot of people and bringing a lot of value to. It's mutually beneficial whenever I see your partnerships. So I really like that about Roboflow.
I appreciate that. Yeah, it's a big space out there, and it's going to take a lot of us to bring computer vision to the masses. And so the more folks that are focused on bringing it to developers, data scientists, machine learning engineers by industry, across backgrounds, it's absolutely the reason why we prioritize education and ease of use. In other words, computer vision is bigger than any one company, so driving the adoption and ease of use is key. So I really appreciate you calling that out. The team at Roboflow focuses on really developing the community and being good partners. So we'll aim to continue that with that strong praise. Appreciate it.
And what a team they are.
Speaking of teams, someone new joins the YOLO team. So YOLO R, you only learn one representation. OneCanU releases this in May 2021. So OneCanU, who was pretty involved in benchmarking the performance of Yolo V4, though was not a listed author, introduces some key improvements, especially cross-stage partial networks, which is one of the key innovations for improving the CNN backbone speeds. And so this contribution actually causes YOLO R to outperform on the COCO benchmark compared to things prior. So as you're kind of hearing here, it's like new model, new state of the art, kind of new tactic and marginal improvement. And of course, as I mentioned, that's key. Calling out YOLO R is key to a new author has joined the primary author has joined the YOLO family. Right after that, we had YOLO S. You only learn one sequence, which is, as you know, transformers and attention-focused techniques and treating everything as sequences is growing in popularity in machine learning, primarily first in natural language processing with BERT and other state-of-the-art models, and now increasingly finding its way and eating into vision models. I think the jury is still out if you can learn all parts of pixel relationships without any level of convolution, but there's been promise and continued research on using transformers and sequences specifically, and they joined the YOLO party with YOLO S October 2021. We actually did a collaboration with Hugging Face, the Weights of Biases, Roboflow team to put together a tutorial of training your own YOLO S model. Now, one thing that I will note is these authors, as opposed to the other time where we said new paper, new state of the art, YOLO S was one where it was introduced, but actually not new state of the art. It was competitive, but not yet state of the art performance. And so we're keeping an eye on thinking through continued transformer-based performance. I'm going to jump to YOLO, the next one in the family, so we can get to the new stuff. Right after that, we get Yolo V6 or MT Yolo V6 by a group out of China. You can kind of think about them like Chinese Amazon, and it's released June 23, 2022. So hot off the summer of 2022, folks are shaking off their COVID legs and releasing new models. And so Yolo V6 is the, it's kind of a marginal improvement in the Yolo V5. And similar to Yolo V5, it actually was released without as much kind of fanfare and people deeply studying kind of some of the papers. There is a literature like what's new release that you can walk through and identify with accompanying Yolo V6, but it's a bit more in the style of like industry pushing us forward rather than just researchers pushing us forward as far as those things kind of go. And you can see the performance in the COCO benchmark that it is marginally better than those that preceded it, which brings us to Yolo V7. Introduced July 6, 2022. The Yolo V4 authors are back. And so Yolo V7 is a trainable bag. They introduce Yolo V7, a trainable bag of freebies, a new state-of-the-art for real-time object detectors. You'll notice the authors here, YOLOv7, Alexei Borchovsky, teaming up and releasing this. And so I think that they were almost waiting for Yolo V6 to come out so they could immediately release Yolo V7. That's kind of
like, I think one week later.
What's going on? Yeah, what was going on in the background, but
so I have this idea. That somebody should release Yolo V8, but then turn the 8 around so that it becomes an infinity.
Oh, see, that's good.
Or they could call it.
Nailed it.
Or they could call it Yolo 8.
Sorry for the Yolo 8.
Oh god, that's bad fun.
And so I guess this begs the question of kind of, so now we're in Yolo V7 land. We've gone through the prior Yolos. What's new? Like, what allows this to be a new performance model? So a few things. There's selective reprioritization, which allows us to keep multiple sets of weights of the network as you're training it. Whereas like every Yolo before it, there's kind of a fresh set of weights as you go through. There's almost, you can think about it like I would almost think, I'm hesitant to use the word like short-term memory because that's not like a formal LSTM or anything. But as you go through training, you're not immediately discarding weights at various portions in the network, and you're learning what those gradients should be, which allows it to learn the target subjects a bit more easier. There's also efficient layers for the CNN backbones. I think that's probably some of the work from One Can Use work with Yolo R. And then there's actually supervising and training of a second head kind of halfway through the network. So Yolo V5, for example, has 3 heads for understanding the size of images and objects. And those heads are basically that are doing, at the end, the softmax for saying, okay, what's the objectness of a model? What's the classification of the objectness that we found in the model? Now, Yolo V7 has heads almost like the second head in training, which I'll talk about this, I think is what is responsible for increasing the training time for Yolo V7, but also allows it to solve. So why would they do this? The why for this is it helps solve the vanishing gradient problem. Whereas, increasingly as you train and you do backpropagation, some of those weights could approach 0 and you get infamously the vanishing gradient problem. If you have a head perhaps midway through the network, it is helping reduce the risk of that issue. And of course, there's more details in the archive paper, and the Roboflow team have also published a pretty good kind of too long didn't read of the archive paper that I'll drop, at least in the Zoom chat. I don't know. We could probably circulate that to everyone afterwards. We usually send an email link.
I'll go ahead and drop it in the show notes. Thanks.
Yeah. Awesome. So that's sort of what's new from the architecture side of things. Now, what does that mean in terms of performance? Actually, there's one other thing that I want to mention with Yolo V7. Yolo V7 is out, and you can see the GitHub, and you can go and visit it, and you can check it out. Something else that's kind of teased at the bottom of Yolo V7 is there's a small note about key point for pose estimation. If you can see, the skier there has their joints outlined, and there's a little teaser for instance segmentation. And so in some ways, I think Yolo V7 is maybe approaching what could consider like a Swiss Army knife of computer vision, of handling multiple tasks at once. And I think that this is quite novel. I mean, there's of course other types of vision problems besides just object detection, and unifying them within a single framework would be really impactful as a step forward for the field. Now you can already try out kind of those pre-trained pose estimation and instance segmentation on the repo, but there's more work to be done here.
Yeah, so I just want to pause a little bit and say that there is some precedence here so if you look at the two-stage detectors, faster RCNN, right? So faster RCNN architecture led to mask RCNN, which was the instance segmentation. So similar kind of thing. You just change a few things, and it becomes a segmentation model. Faster RCNN was an object detector, and then you change a few things, and it becomes an instant segmentation thing, and then you change a few things more, and it becomes a key point detector. And I think that paper is called key point RCNN or something like that. I cannot remember right now what is the name of the paper, but there is this precedence that you have learned something, right? And it is useful for multiple tasks, right? The features that you have learned, it is not just for object detection, but you can change the final output head slightly so that you get all these things. They're almost free. You have already trained the model, and these various things. It's the same, how you interpret the output is, you can get an object detector, a segmentation, as well as a key point detector by training a single model, right? So that's really nice that it's presented in a single architecture, a single network. You don't have to run separate, but the idea was there, with faster RCNN, mask RCNN, the idea was there. It's nice to have it all come together.
Absolutely. I mean, to your point, like learning representations and embeddings of images and pixels is useful for multiple tasks. And that task could be one that is, drawn a box with 2 vertical X coordinates and 2 horizontal Y coordinates, or it could be useful for, doing instant segmentation or even key points. So yeah, I think you're exactly right. It'll be interesting to have it kind of in a specifically unified architecture, like almost like one repo, one paper kind of thinking. Now, Yolo V7, we talked about, or sorry, did you want to chime in there, Phil? I didn't want to interject.
Nope, I got nothing.
So there's this question of how good is Yolo V7? And this is sort of like what I've been teasing at the beginning and some of what we've been talking about. So on Cocoa, Yolo V7 Cocoa performance is published to outperform Yolo R, Yolo X, which we didn't even talk about, Yolo V4, Yolo V5, PP Yolo R. We didn't talk about PP Yolo or PP Yolo R, paddle implementations.
These names.
There's only so many Yolos you can fit into 1 hour, right? And you'll note here that it both notes that it's faster and more performance on the Microsoft Cocoa object detection benchmark, which is super exciting. Introducing new state-of-the-art, verifiable, continue to do results. Now, there's been interestingly, I think that this isn't really a critique of Yolo V7, but I think of computer vision more broadly. I think there's been Cocoa benchmark saturation. As in, the Cocoa benchmark may not be the best benchmark for identifying computer vision model generalization, right? New state-of-the-art models make marginal performance. Those marginal performance may be overfit to do things for Cocoa. Like, for example, like the bag of freebies that exist in training, do those bag of freebies generalize to all types of recognition and detection tasks? Do they learn everything equally? And Cocoa, of course, includes a healthy set of 80 classes, but many of which are not tasks that people are using their computer vision models for. Let's say you're doing an aerial task where you have a drone and you're looking at roofs to try to find insurance and damage detection. Let's say you're looking underneath a microscope to look at cells to count cell culture populations for accelerating cancer research. Let's say that you're doing manufacturing and there's very small defects that might appear. Or maybe you're doing document text extraction. You're looking at documents, or you're looking at screenshots. And you're trying to identify what's in a given screenshot. All of these are example tasks that people are doing in computer vision, people are doing with Roboflow that we don't see represented in the Cocoa benchmark. And so I think researchers have become attuned to this idea of Cocoa benchmark saturation. And for example, when Florence was published, which was a new state-of-the-art model that the Microsoft research team published in November 2021, they actually benchmarked their zero-shot capabilities of the model on a collection of public benchmarks. And that public benchmark is kind of screenshot on the right side here of the paper. And I'll talk through that more in a second. But Satya, I'd love your thoughts on like this idea of Cocoa benchmark saturation. Is it real? Is it cause for concern? What do we think about this?
Yeah, it is. It is a cause for concern. I mean, a lot of, and it's obvious, right? I mean, you give people or machines an objective, and they will achieve that objective even by hook or by crook, right? So once you have this data set, they are training it again and again. That's the single focus. And I'll give you an example how even in the Yolo family, right? Initially, when the anchor boxes, the boxes that are used were not trained. They were handcrafted, right? So they fixed the size of the boxes based on, what are the most popular sizes, right? They would handpick these things. Now things have changed. Now it looks at the data and then selects the size of the anchor box or the aspect ratio of the anchor boxes. But initially, they had tweaked it so that it worked on ImageNet very well. But if you, let's say, went to another data set where they had very long objects, then it would not work, right? So later, they obviously went and fixed it. And now, the aspect ratio that is used by anchor boxes, they are learned from the data itself. So that was one example where, you had almost hard-coded things to make it look better for that particular data set. And that's an obvious one, but there are several other things that people might be implicitly doing without even realizing that they are trying to beat the benchmark. So that's a problem with any benchmark, actually. But you're right. I agree with you.
You see this this has been a thing for years in graphics cards. So, gamers started caring about the benchmarks of these various GPUs. And so then they started building the GPUs to cheat the benchmarks. And so then they had to get the benchmark folks have had to get a little more clever with how they benchmark these things and try to detect if you're cheating. But maybe ATI or NVIDIA is a partner, and so you don't want to make their benchmark go down even if it's more accurate. And so you get benchmarks get us into all sorts of trouble, I guess is what I'm getting at.
I think that's
They're
right.
still necessary. It's one of those things, necessary evil.
Yeah.
That you need them. Otherwise, you don't have anything. But then you don't rely on it exclusively to judge how something is. It is
Right.
for guidance.
Yeah, it should be one aspect that you look at, but not the whole thing. Definitely.
I think that's exactly right. And so the Microsoft Florence team, I think, kind of also has been wising up to this idea. And so they used community benchmarks. Of course, they published their results on Cocoa, but they also benchmarked on things like chess pieces, BCCD, pothole packages, mask wearing, all these ideas of other places to assess zero-shot capabilities. And believe it or not, this was organically pulled from Robophil Universe, of places where there are already public data sets. And so if you're listening to this webinar, you are helping push forward the state of the art from contributing and making your data sets available in a public way for other researchers. I mean, this packages data set, that's a package outside someone on the Roboflow's team. Just when we were collecting a data set to make an example of what a package data set could look like. I mean, that thermal data set was me plugging a thermal camera into my iPhone and capturing some photos of a parent and a dog. And so my dog there, his name's Bear, is forever famous as a part of a benchmark here. And so not to mention that chessboard that I'm all too familiar with. I mean, if you're a Roboflow user, you've seen this chess data set as well. And then there's other community ones of people going to the aquarium and listing those, or pothole, or finding smoke. And I think this is in Pacific Northwest. And I think this actually just is actually almost like a call to action, that if you share your data set in a public way, it allows the community to move forward with these types of benchmarks and these ideas. And so we kind of began to ask ourselves, what if the community is the one informing this performance? Like, what if we help aggregate some of these examples? So we went ahead and said, okay, let's grab some of these high performance data sets we're seeing users create and produce in an open source way, where they're setting the license, and you have things like solar panels, cells, paper parts, aerial pools, Valentine's chocolates, that one's for you, Phil, chess pieces, and everything in between, right? Of everything that you want to see. And we actually, we kind of are thinking about what would it be like to have like 100 of these examples at some point, and maybe 1,000, and so on and so forth. And basically you could check model performance and compare it to specific types of tasks. And you could begin to ask yourself, okay, so the COPA benchmark is useful for common context in real life, people detection, car detection, fork knife, these sorts of things. But what if you're working on aerial, or what if you're working on document extraction, or things like this? How good is the model then, or how good do you think it is for your domain problem? And so I guess the answer is we've done some of this, and I put a link in the chat of some of the first 100 that we've kind of aggregated here. But we ran. Hope you're on the edge of your seats here. We ran Yolo V5 and Yolo V7 on an initial set of some of these benchmarks. Now, these are very preliminary results, so I wouldn't read too heavily into these. There's more that we want to do. There's only about 50 data sets that are represented. There's more work to be done. But with the way we structure this test is we took basically 50 public data sets, and we did 40 epochs of early stopping for Yolo V5 and Yolo V7, which means the model trained until there were 40 epochs of no improvement in the loss function, right? And then we said, okay, which models did we use? We used the same ones that researchers use for comparing on the COCO benchmark. So Yolo V5S compared to the base Yolo V7 models. So about 7.2 million parameters. Yolo V5 model, about 37 million parameters in the equivalent model. Pretty similar to 6 frames per second. And we went ahead and said, okay, let's run this and see the results. And so the initial results on just 54 data sets indicate that there might not necessarily be a broad-based, generalized, better performing model between these two. So on the COCO benchmark, as we described, Yolo V7 outperforms Yolo V5. In some of these categories, we began to see something that's kind of interesting. Like, I think aerial images require a deeper set of investigation because the gap between the blue Yolo V5 and the red Yolo V7 begins to call into question, is that a domain where Yolo V7 might not perform as well as Yolo V5 does out of the box, right? I mean, you could always fine tune and change things. And there's different domains of like real world, similar to some of the Coco ideas, the video games, microscopic, document extraction. And initially, this kind of suggests that these community benchmarks may be really helpful for beginning to drive some sense of asking deeper questions of domain specificity, domain adaptation. And we begin to ask ourselves, why do we might be seeing the change? And one of the biggest things is actually what Satya, you mentioned earlier, the anchor boxes. In Yolo V5, the anchor boxes, there's actually a genetic algorithm that runs at the beginning of training that says, where should the anchor boxes be? Many other models have hard-coded anchor boxes, which doesn't do well with odd-sized objects, or maybe small objects might not perform as well in this. So if you have a box that's really long and narrow, for example, and it's consistently on a given part of the image or things like this. And so I think this is, of course, this requires deeper investigation with a broader, I think I want to do like a larger basket of data sets. I think trying out different parameters, but these are just some initial preliminary looks of how things were looking. And I think that the point here is increasing the number and quality of data sets that are publicly accessible and benchmarking those models, and then basically kind of doing your own research. And so this was kind of the initial early results of seeing some differences in mean average precision and performance between these models.
This is great. One other thing I wanted to point out in the slide, this is a really good slide. If you look at Yolo V5S, which has 7.2 million parameters, and Yolo V7, which has 36.9 million parameters, you can see that the number of parameters has gone up substantially, which means
drastically,
that, right? But look at the FPS, it's actually faster, right? Yolo V7 is faster. And this was one of the things that caught my attention also because, if you look at even the Yolo, the evolution of Yolo and other object detectors, a lot of times you would imagine that the number of parameters and FPS, there would be a correlation. You have to actually go through a larger network. You're doing more calculations. And therefore, the frame rate, they should match up, right? But there is much more going on. In several optimizations done in the Yolo V7 paper, they make sure it's not just the number of calculations you have to do, right? It is how accessible those things are in memory, in GPU memory, how close they are, and if they need to be reused, how accessible they are, things like that, right? And there's a lot of optimization about I/O channels, etc. So you can see that there is a higher FPS, even though this is a bigger model for Yolo V7, which is, so just looking at the model parameters is not enough. You also need to look at, what is the real world FPS.
And I think the maybe anticlimactic conclusion to some of this, maybe not anticlimactic, I don't know, is as it relates to knowing model performance, the best answer is trying it with custom training on your own data set, right? Try it yourself and see if this change in performance is worthwhile. Now, of course, just because there's a new version bump doesn't immediately mean that you should rip out all of your old architecture. There's other considerations about you've already got it deployed, or maybe you've already got some of these other things kind of configured and those sorts of things. So there's an assessment that should be done and say, is this, well, one, is there a difference in performance? And two, is that difference in performance great enough that I want to maybe rebuild or change, replace, or upgrade, or some of these, rebuild some of these things? And so we've put out a how to train Yolo V7 on a custom data set. I actually also have linked in here the Colab notebook that is immediately usable for training a custom Yolo V7 model on your own data set. Now, notably, a small kind of word of caution here, Yolo V7 trains seemingly slower than Yolo V5. It's not like Colab can still handle both tasks, but I think it's the result of some of what we described earlier of the introduction of new heads and some of the other considerations. I mean, obviously it's a higher number of parameters, so some of that makes sense that it would take a bit longer to train and optimize. And so I strongly encourage the, kind of do your own research approach rather than just immediately saying, okay, Cocoa is better, or this is better, or this benchmark, or this sort of thing, just as we were describing, because it's always better to assess and kind of get proof in the pudding in terms of determining what's going to be best for a given result. So that's kind of maybe the anticlimactic conclusion is there's no free lunch, and doing your own research is often the best way to make a independent conclusion. And I thought that would be at least an initial way to get discussing and started, and we can move towards some Q&A.
I have one more thought that I did not complete my thought on the Cocoa thing that you mentioned, that okay, these could be over optimized for Cocoa. So there are these networks, Efficient Net is an example, which have been they have been trained for the specific, it's basically a very big search for different architectures which work very well on these benchmarks, right? So they produce state-of-the-art results. And I was looking at some of these paper in the medical community, and I was seeing that these people are still using architectures which are 2-3 years old. Why don't they use newer architectures, right? You would imagine that because it's doing well. So medical community, they obviously, my initial thought was that, oh, these guys are not, state of the art. They're the medical community. They are not the computer vision community. And so they are lagging behind. And, but that's not the right answer. It turns out that a lot of these newer models, especially the ones that have been optimized, using very large, optimizations, in those cases, they are overfitting on the benchmarks, right? And so when you take these models and try to run it on a different domain, like a medical data set is very different from regular RGB images, they don't perform as well. And so the medical community doesn't adopt them, because even though on paper they work very well on ImageNet or MS Cocoa, in their domain, it doesn't, when you try to fine tune it, etc., it doesn't do a very good job, right? So that is why I think, what Joseph is saying is that you should always try to see it on your own data set. And there are always other considerations, like what platform you're running it on, right? What is the compute capability of your device, CPU, GPU, VPU, etc. And sometimes you need a smaller model, right? Like you saw with Yolo V5, it was just 7 some million parameters. And that's crucial for you because it's a smaller model. It expands, it takes lesser space in GPU memory and things like that. So those were the closing thoughts.
Yeah. Any response to that, Joseph?
I think this kind of is where we will go from here, right? So I think that we'll continue to see models probably benchmarked on Cocoa, though I think that there will be Cocoa and that could be a domain-specific benchmark. It could be a generalizable kind of community-led benchmark, as we're naturally seeing with the Microsoft research team and some of the work here that we're seeing of Yolo V5, Yolo V7, some of these. And so I think that like there'll probably be a fracturing, right? There'll probably be like models that get incredibly domain-specific, and maybe even the architecture and the task and the size. And then you'll have like mega models, and the mega models that solve a large array of tasks. And then like in between, you'll have like either fine-tuning of mega models, or like basically taking what a mega model knows really well and then taking that data and putting it into an architecture that's a bit smaller for the task at hand. So yeah, I think that the idea of benchmarking, I think what we're aiming to do is elevate the consciousness of the community, continue to encourage the important work that exists for doing open source computer vision dataset work. And your dataset, who knows, might be cited by the next Microsoft researcher for publishing the state-of-the-art paper.
Yeah, definitely. So yeah, I think let's go ahead and do our giveaway here. Before that, I'd like to remind everyone that we are taking your suggestions for the name of the cat. If you stay tuned after our giveaway, I will read out some of the suggestions that y'all have sent in. Thanks so much for sending those. So If this is your first time joining us or you just need a reminder, every week we give away something to you, our audience. One lucky winner in the Zoom chat will win a Roboflow swag bag if they're in the United States, or the OpenCV course of their choosing if they are not, as well as some Roboflow GPU credits courtesy of our dear friends at Roboflow. If you have won our trivia giveaway in the last couple of months, last 2 months, please don't answer and give other people a chance to answer. Also, if you answer before I finish asking the questions, I will disqualify you immediately. So get ready to answer here. This is for Zoom.
He's the socialist. He's the socialist in this group.
Anarchist socialist, please. So earlier in the presentation, Joseph talked about a milestone, a 1-year anniversary for a specific feature of Roboflow. What is the name of that feature? And it looks like Sesu got it. There's Universe. Roboflow Universe is the answer. Please send one email to phil@opencv.org, and I will make sure that you get your choosing of the course, or if you're in the US, the Roboflow swag bag, as well as the Roboflow GPU credits. Congratulations.
So I have one little story to add. You remember Joseph mentioned that his dog is part of a data set now, and so
yes.
The dog is famous. I had this very funny incident that happened when I first went to a major conference. The first day of the conference, I would see some person and I feel that I know them, but I could not place them. I could not figure out the name, etc. And this happened a few times, like 4 or 5 times. And I was thinking that maybe I'm tired. I can't remember the names. And then I figured out, yes, these people are all part of the face recognition data set from Yale. These are professors.
Wow.
Right? So it was funny.
David in the chat says they're data set famous.
Yeah.
That's great.
New depths of fame we've invented here. That's a good one. So yes, as promised, I'm gonna go back to our beloved kitty cat here. Does not have a name. Some of the names that have been suggested so far, hyperspectral analysis suggested Blob, not bad. Zach Crane suggested Pip, Epox, or Edgy. Tim suggested Meowon. Morgan suggested Gigi. Beth suggested Ilya. Isla, which is an interesting combination of Phil and Satya. Isla. Those are what we got so far. Please send your suggestions.
I think last week somebody also suggested Schrodinger's cat, which I found very funny.
Schrodinger. Yeah, Schrodinger. Yeah, excellent. That's a good one. Fernando in the chat here says YOLO cat. Lewis says RoboCat. I mean, the cat's not technically robotic, I don't think, anyway. We haven't really decided. The backstory is to be determined. Let's do a couple questions here. Norman would like to know, what can we expect from Yolo V8? It should be coming out any minute now, based on the historical record. Joseph, thoughts?
A big splash and some naming controversy. Probably... I would suspect if the current trends kind of hold, I would be unsurprised if it included something with transformers. The other thing that I'd be very unsurprised of, and this is my leading bet, is that the team at Ultralytics put something out on this in the next probably, I don't know, before the end of the year would be my bet. Now, in terms of what would be new in it, well. You know, what's interesting is that Yolo V7 increases the size of the model by introducing this new head and makes use of representation learning. So I bet both those will be core components of the architecture that seem to be kind of solidified as valuable. I think we'll probably see another model focused on being released natively in PyTorch. I think that's a safe bet. And then likely a state-of-the-art, Cocoa performance change, and then I'll be interested in seeing how does it compare to some of the community benchmarks. So I think the usual, right? New model, perhaps new Cocoa state-of-the-art, introduces some of the same things from before. Authors probably being some of the Ultralytics crew from some of the work that they've done in Yolo V5. I feel like these are sort of like earthquakes, and it's like that's the next region that's in the world that's overdue for some new noise. So some initial high-level predictions on author resources and outcomes.
Makes sense to me. Sounds good. Satya, thoughts on what we might see in Yolo V8?
Well, so the trend of having a single model for segmentation, for detection, segmentation, and key point, that may continue, right? And it may also extend to other objects, not just humans, right? For example, key points may be useful for animals and cars and things like that. So that will continue. And obviously, I'm surprised how much performance they have been able to extract from from as far as frame rate is concerned. So that will keep going up, and the model size hopefully will be squeezed. And one very nice trend is that all these groups have been publishing several models, right? They don't publish one model. They publish a collection of like 5 or 6 models, which are appropriate for different use cases, right? There is a tiny, small, large, extra large, etc. So that trend is also a very good trend. Really like that, and that is going to continue as well.
Andre would like to know general advice. Do you think that broadly, if people have a working Yolo V5 system, should they transfer to Yolo V7 or just kind of keep working with what works? I'll go to Satya first on this one.
Well, I think it's very domain specific, right? You have to try it. There's no harm in trying. And trying these things, the beauty is that all these, the code that people have released, they are very high quality. It doesn't take you a long time to train these things. You can spend, a couple of days maybe, and if you get a good model, then why not, right? And it's not like these are dramatic changes, right? You can easily swap out your model if you stick to the framework, right? If it is, going from darknet to PyTorch, then there may be a difference. But I would definitely try it, give it a try. Whenever these new models come and there is a big splash about it, there is a reason, right? Because the frame rate has increased, the accuracy has increased, and you almost get, a freebie upgrade. Mm-hmm. So why not try it, if it works on your data set?
Joseph, thoughts?
I think that's exactly right. I think the advice I gave previously of try to, it might not actually be better on your data set. So try it on your data set to see if there's even a given difference. And 2, there's a lot of architectural work that may have gone into a given prior decision that the decision isn't purely based on, accuracy or speed. There might be other considerations of where the model is deployed or the ability to update it or maintainability of that pipeline overall. So like most things, I would stack up the benefits of, how big of an accuracy bump is there, how big of a speed bump is there, how much of an ease of use bump is there, and compare that to the costs of, retraining, redoing some of the architecture and seeing about maintainability. But it all starts with, I think, getting a first look at a very lightweight way of comparing, which might be like a sample of a data set thrown into Yolo V7 and a sample of a data set thrown into Yolo V5.
And
seems reasonable, yeah.
If you already have your data in Roboflow, then training this thing
super easy.
Is probably, yeah. So why not, right? If you already
how many clicks would that be, Joseph?
If your data's already in, you would have to click export, and then you'd have to click Yolo V7, and you have to click confirm. 3 clicks.
Oh man, that's so many clicks. I don't know. You lost me. You lost me when you did more than 2 clicks. I can't do that.
But the pid package snippet would already be written for you. It'd just be copy and paste into your Colab notebook, Phil. So how about that?
All right, you won me back.
All right.
We're getting pretty close on time here. Satya, would you like to take us home?
Yeah, I want to thank everybody here. Joseph, a great presentation, and I really like what Roboflow is doing, and also, your own benchmark that you tried it. Not just you just did not publish what what's out there, you guys actually did it and shared it with the community. That's really good work. And thanks for being here. And these webinars, we get a large audience whenever you are there. So it's great to have you back.
Thanks for having me.
Joseph is quite the draw here. I think we hit we're about 220 concurrent viewers today for those keeping score at home. So yeah, thanks again for this is what, appearance number 4 for you, or 5?
I think 4 is right. Yeah.
4?
Thanks so much for having me as always, and we'll continue to do our best to elevate the best voices across the community and cultivate ease of use computer vision everywhere. Always a pleasure.
What a team and what a guy. Thanks, Joseph. Yes.
And
so,
I also want to thank Phil Nelson, who puts these shows together, and he's been working with the Light Twist team for the studio. And so thank you, Phil.
Yes,
I have one last.
Go ahead.
I have one last announcement before I'll let Phil take it home. Cvat, computer vision annotation tool, has recently found a new home. OpenCV is going to become the official maintainer of the Cvat library. This library has been developed for over 5 years by Intel, and recently they're such a Intel. I find Intel is a company which is the incubator of a lot of open source libraries and tools, like
much
OpenCV
like OpenCV.
Exactly. So OpenCV also was at Intel, and then OpenCV.org started maintaining it. Similarly, Cvat will now be maintained by OpenCV. So check it out at cvat.ai. And again, we'll have some integration with Roboflow as well in due course of time. So
yeah, I think we're going to do some competition, the next competition with some of that together. So stay tuned.
Ooh, did I hear a competition? You folks might want to stay tuned for that later.
There is a competition coming in about a week or two. We'll keep you posted. So this is OpenCV AI competition, and there will be 2 tracks for the competition. One would be a general track where you can submit any kind of application, and then the other one is a spatial AI competition where we have a very specific task this time, where the idea is to improve the depth estimate of coming out of OAK-D, so OAK-D Pro. The details will be coming in the next 1 week or so. Stay tuned for that as well.
And the best way to keep abreast of that situation is by subscribing to the OpenCV newsletter, opencv.org/subscribe. I am Phil Nelson, the co-host with the co-most, your plus one and only. If you can't get enough of me, I have good news for you. Premiering in about 20 minutes is the Light Twist show. So look for Light Twist app on LinkedIn, Twitter, and YouTube, and you will see the very first episode of the Light Twist show, which I am hosting with Light Twist CEO Vikas Reddy. Our guest is Jeff Powers. Jeff and Vikas previously had founded Occipital together. We had a fun, free-ranging, hour-long conversation about the crazy tales of early days of Occipital, and most of the team not making a flight to Israel, and PrimeSense being bought by Apple right before our Kickstarter campaign, and all sorts of stuff. It's really fun. I hope you will tune in. That's Light Twist app. As always, we do OpenCV Weekly Webinar every Thursday morning, 9 a.m. Pacific. Same bat time, same bat channel next week. We will see you then. Turn on our little outro sequence here. Gosh, this was does anybody else just coasting on fumes today? I feel like this was one of the roughest shows we've done. I'm flop sweating my ass off over here. But we did it. Thanks so much, Joseph. This really was fun. I learned stuff. I always like it when people come on the show and I learn stuff. That's really what this whole thing is about, right? Me personally learning things. Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by OpenCV Courses. Learn computer vision and AI from the best at opencv.org/courses. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.